What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 3.6, so proving angle relationships. I think the learning target in my video for 3.5 matched this one. So yes, now we'll talk about all the definitions of congruence when we see angle bisectors, complementary, supplementary, perpendicular, and right angles. We'll also be able to apply the angle addition postulate and the protractor postulate in a written two-column proof and how they can support each other in that, and then finally use the vertical angles theorem, complement theorem, and supplement theorem in a two-column proof. Before we get started, we got to know what all these definitions mean. So I went ahead and just had these typed in for you just because it was a lot of writing and easier to just have them written down. This is something we should already know. So this is kind of like a review from Unit 1. Definition of congruence just means we can say the measurement of angle A is equal to the measurement of B, or angle A is congruent to angle B, and that goes vice versa. A bisector is when you have an angle being divided into two equal parts. The definition of complementary angles just means they can be complementary if their sum is 90 or they have a sum of 90 degrees. That means they are complementary. Same thing going for supplementary. That means we have two angles added together equals 180. Perpendicular lines are going to form those right angles, and a right angle is equal to 90 degrees. So we got all those written down. We'll see a lot of them here in our notes in just a moment. Let's talk postulates. An angle addition postulate just says we can add two angles together and it can make a full angle. So we can say maybe this, the measurement of angle ABD plus the measure of angle DBC can be equal to the measurement of angle ABC. So we're just adding those two smaller angles together to get our full angle. And then the protractor postulate, which we don't see often, but just a good thing to know. Every angle has a measure, in this case between 0 degrees and 180 degrees, okay? Yes, we know that we can do like a full circle of 360, but that is not going to apply in this unit currently. Next up, we're going to talk about vertical, complement, and supplement theorems. If two angles are vertical, then they are congruent. So I'm going to put my symbol for congruent there. If two angles form a right angle, then they are complementary. And just remember, complementary means 90 degrees. And then if two angles form a linear pair, then they are supplementary, which is 180 degrees. And again, keep this in mind. We can still use all of the properties of equality and the properties of congruence. So today, it's like we're putting all these properties together from what we've learned in Unit 2. Let's go ahead and turn the page and look at example 1. So example 1 says, given that angle 2 is equal to angle 3 and angle 1 and 2 form a linear pair, let's prove that angle 1 and 3 are supplementary. So we are given our statements first, so that's statement 1 and reason 1. And then let's look at statement 2. It says the measure of angle 1 plus the measure of angle 2 is equal to 180. We can maybe just say that's the angle addition postulate. Okay, because it's already telling us they're a linear pair, so that means we already know they're 180 degrees, so we're adding them together to prove that. Now it says the measurement of angle 2 is equal to the measurement of angle 3, and that was a part of our given. Just notice that we've taken away the congruent symbol, so this is probably the definition of congruence. Okay, next up for statement 4, the measure of angle 1 plus the measure of angle 3 is equal to 180. That looks like we just used substitution, where we substituted out 2 and 3, because 2 and 3 are equal. So that would be substitution. And then finally, angle 1 and angle 3 are supplementary because we just used the definition of supplementary angles. Got kind of cut off there. Angles, perfect. Okay, let's go on to example 2. If you want to pause the video at any time, try this one on your own and then click play to check your work, you can. But if we're ready, let's go ahead and get started. All right, we're given that angle 1 and 2 are congruent. We want to prove that angle 3 and 4 are congruent. So we've already got our statement 1 for given. I'm going to go ahead and say that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4 based on the vertical angles being congruent theorem. And then I'm going to use the symmetric property of equality. I'm going to just focus on this first one. So angle 3, put that one out in front, is congruent to angle 1. Once I have that, then I can maybe substitute or use a transitive property to say that angle 3 now is congruent to angle 2. We'll say transitive property here. And last but not least, angle 3 can be now congruent to angle 4 by using another transitive property or a substitution. Right, or sub. Okay. Example 3 is kind of a doozy, but I still want to see if you can get started with this one on your own. I did end up using a lot more lines than just 5 here, so keep that in mind. I think for my example, I used all the way up to 8, and that would be okay too. So my apologies for not giving you more time or more lines. Let's go ahead and pause here, see what you can try on your own, and when you're ready to click play. All right, we are given that DF, which is this whole entire line here, is perpendicular to GE. So if you even need to put a little right angle notation, you can. And then it says angle 2 is congruent to angle 3. I want to prove that angle 1 is congruent to angle 4. So we've already got our givens. What I would do next is probably talk about the measurement of angle DBE is equal to 90 degrees, and the measurement of angle FBE is also equal to 90 degrees, and that would be the definition of perpendicular. Okay, once I know that, then I can maybe say that angle 1, the measurement of angle 1 plus the measurement of angle 2 is equal to 90, and the measurement of angle 1 plus, not 1, but 3 plus the measurement of angle 4 is also equal to 90, and that would be my definition of complement, or even my complement theorem. Okay, next up, statement 4. Now I can maybe say that the measure of angle 2 is equal to the measure of angle 3 using that definition of congruence. And because measure of angle 2 is equal to the measure of angle 3, then I can say the measure of angle 1 plus the measure of angle 3 is equal to 90 degrees using substitution. So that, this is when I maybe went too detailed here, the measurement of angle 1 plus the measurement of angle 3 can be equal to the measurement of angle 3 plus the measurement of angle 4. And that one I would say is more specifically transitive because you're using kind of like a law of syllogism here. And then statement 7, then I use subtraction to say the measurement of angle 1 is equal to the measurement of angle 4. And then finally for statement 8, angle 1 is congruent to angle 4 using the definition of congruence. So I'm trying to get that symbolism there to match what my proof says. Okay. All right, last one, example 4. FB is bisecting AFC, and I can say that angle CFD is congruent to angle BFC. So can I prove that AFB is congruent to CFD? This one you can get it done in 3 reasons. Let's go ahead and just finish it up together. Statement 1, I'm going to go ahead and write my reason, my given. FB is bisecting angle AFC, and angle CFD is congruent to angle BFC. Okay, I know then, because of my bisector, that angle AFB would be congruent to angle BFC using the definition of a bisector. And then statement number 3, then I can say that angle AFB is congruent to angle CFD using that information right here. So that could be transitive or substitution. Okay, look good. That will conclude all of our lessons in Unit 3 about proofs and writing proofs and logic. Hopefully this video helped you. Tune in next time when we start to review for our Unit 2 test. Have a great day. Bye.